Yo! Hey guys, it's been a while. Welcome to another episode of Ferris Makes Emulators, where we're still working on that N64 emulator, and probably will be for a very long time. Is that Genzume? I'm not sure. I've been looking forward to the next stream. Glad you found some time. Thanks. I do want to address that in a second. The Zepeth, I noticed you use a mechanical keyboard. What switches do you have? They're cherry reds. Hunt CS, yo. Anyway. Yeah, so it has, to address the elephant in the room, it has been a while. It has been, like 2 months and a week since I streamed last. First of all, that was never the intention. I'm not going to apologize for it because I think I have legit reasons for doing that, but, it is kind of a bummer and I understand that, so I'll work on, just getting better and, being more consistent with when I stream. Just a lot of things happened. Work was super busy. I got sick for a while. I got a tooth pulled. That's pretty fun. Looks pretty messed up. And yeah, I mean, just been really busy. Other thing that's happening is there's a demo party coming up, and someone got a little competitive, so I've been working on some of that stuff. Haven't been streaming it mostly actually because I hate using this really big font, but maybe that'll change now that some of this stuff is sort of more set in stone. Yeah. Anyway, you guys are here to see some N64 stuff, so let's start hitting that. I thought about this earlier. It's actually kind of funny that the fact that I didn't stream for a while and now we're coming back to it simulates a very important part of the emulator process, which is where you literally don't touch the project for a while, and then you start touching it again and you don't know what you're doing. So that's going to happen today. Totally not the reason that happened, but, Anyway, yeah, I guess we start diving into this. So I really don't remember where we left off. So I guess I'll just start with pull requests because there were a couple. In fact, there were a couple like right after my last stream. ProMan21, Juggle Tux had a couple. And I didn't address any of those till now because I haven't streamed since then. So for this, I'll get to this first one in a second because I'm actually, it failed the AppVer test earlier and I think it was just a fluke, so I'm just running them again. So we'll do the second one. Support special instructions in debug. So this was ProMan21. I believe just implemented some more, just printing stuff for our opcodes because we started decoding the special opcodes, and yeah, those would just print out as like special or something before, and so he decided to fix that. So that's pretty cool. It's very helpful. So that's an easy one to merge. So thank you, ProMan21 for that. Good stuff. And how's this other one doing? This is probably gonna take another 5-10 minutes. Oh, hey, wait a minute. Nice timing. As soon as this goes green, then we'll merge because principle. Or did this queue? Oh, no, that's because it's running the latest build. I had that wrong. We want to look at this. It's because I just accepted the pull request. Yeah, so that's still running. So that'll be a little bit. So I'll just let that sit. Yeah, and I guess I need to figure out where we were. So I'm just going to look at some commits. You may see what song I'm listening to pop up in the corner here. If it were up to me, I'd play all this stuff on the stream, but I want to be able to upload this stuff to YouTube, so I can't do that. But I have no problem sharing my music. So the last thing it did looked more PIF progress, and of course more instruction registers along the way. Finally touching cart ROM. Oh, are we now? Oh, are we now? Sorrel or. codes. Just reading through. Not much to comment on here. I guess. But I think all it was, we just literally hit instructions that hit cart ROM, which is cool. Actually, I think we can go into the releases. So one of the things that I do on this project is on the GitHub repo, I tag all of, like, when I'm done with an episode, I tag, I just tag that last commit with like, oh, this is where we ended at episode 7. So this might actually be quite helpful for me. Or does it not give us the individual commits? That would make sense if it didn't. But I think actually it was only like that one commit for that day, other than some pull requests that we did. There's a Peth. Do you have any realistic expectations for this project, or are you just programming for fun? First time watching the streams. So I just, like, the goal of this project is not to like necessarily make a production quality emulator yet. I wanted to learn this hardware, and I wanted to broadcast the entire process of doing an emulator. And that means I don't do like any research off the stream. So I finally, excuse me, getting mixed up reading the chat. I haven't done this in a while. So I don't really have any like concrete plans for the project, except like start getting stuff working, because it's just kind of where you have to start. And today I think we're actually going to cut some corners. I've been thinking about how we're going to start doing the coprocessors, and I think we have to start that today. Anyway, in terms of like expectations for the project, maybe, when you're streaming everything, the biggest thing that I found that takes away from the project is those times where you have just like an hour to just bang something out on the project. I tend to miss out on those. So the project will take a lot longer, and I expect this project to get to, like, I don't know, what is episode 8? I expect this to be 50, 100 episodes if we're actually going to get anywhere. Critters, don't cut corners, dude. Think of the poor corners. The particular corners I want to cut is that the N64 has a couple coprocessors, like the CPU, and it has a vector processor, and I think we're going to have to start emulating the vector processor soon. And one of the things about these two processors is they run at different speeds. So like the CPU is like 100 megahertz, and the coprocessor is, I believe, like 60 megahertz. And I'm just actually going to decide that they both run at the same speed, at least for now, because I think that will simplify a lot of things. And yeah, I mean, I could go in this with like 100%. Yeah, I'm doing everything for accuracy, but frankly, I don't think we'd get a lot done with doing that and having to stream everything. I think that the better choice is to just make kind of a crappier emulator, even if it might work, and then kind of make that progress, and then start, hammering down accuracy once we have something that works relatively well enough. SpaceCat64, nice to finally be seeing one of these streams live. Sadly, I'll only be able to watch for half an hour. Sorry to hear that, but I am recording everything, so it'll go up on YouTube pretty quick. Yeah. How's this doing? Last piece. Yeah, so I think all we really did last time was just make general progress on a bunch of these instructions. Looks like we got, is SRL, is that a shift left or shift right logical? Might have been what that was. That's what it looks like it was. And then jump relative. Is that jump relative? Because it's just a jump here. Can't remember these instruction encodings. This is what happens when you take 2 months off, but this is a very real part of the project. And then OR. And then some formatting stuff. Yeah. Cool. Anyway, so where are we now? Just go ahead and run this. Oh, by the way, I finally upgraded my Rust. A bunch of guys were giving me crap about that last time. As I was on, what was it? This is 1.1 or 1.10. I was on 1.7 nightly, which means my Rust was like 5 months old. Whatever, still works. Okay, so Oh, I know why this is breaking actually, because we aren't also using the PIF. There we go. Nice. Now we actually have some instructions executing. Cool. And we panicked at unrecognized physical address. Okay, this is a much better place to start. So now we can actually see what we're doing. Yeah. By the way, guys, let me know if streaming some of that demo scene stuff, it's basically graphics programming, is interesting to you. Also, I started another fun little project that I might want to stream some of. It's called Elm Steroids. I decided to check out the programming language Elm. You know, I've done a bit of Haskell, I've done a lot of F# in the past, and I just thought it'd be fun to try and make a little game in that. So I do actually have that, yeah, have an Asteroids clone that I'm working on. That's going pretty well. I actually quite like how the code's going in there. I really miss do notation in that language. It's something that Haskell has to handle monads that I really, really wish Elm had. But anyway, I might stream some of that later as well. Okay, so it looks like this build finished. I'm actually going to accept that really quick. Or this test. So what this was a pull request from JuggleTux. Remove and deny trivial casts. Need to cast to U size. No need to cast to U size to U size. So I think he just removed some redundant casts that I had, probably from when I changed stuff. And then he added to the main part of the project that it will deny trivial casts, so it will actually raise some errors. Yeah. Or actually, now that I look at this, trivial numeric casts. Wait a minute. Is that in? Okay, so now it's just Googling for me, but correct me if I'm wrong, but trivial numeric casts will allow trivial numeric casts to just happen on their own, right? Because actually, that's not something I want when I look at this, even though this is trivial. Where is this? This was in CPURS. Line 139. Yes, the cast is here, and this is it as it normally is. So I cast base as U size because I take the RS instruction from here. Let me look at instruction. I think it's in CPU instruction. RS does, yeah, okay, so this does go to a U size. So that, first of all, that is correct then, definitely. Oops, different pull request. But I want to see actually, so that's what this denied trivial cast, but trivial numeric casts. I wonder if that's just like, this is for numeric types like it was here, and then the trivial casts are for other types. It's probably what this is. Okay, now that I've looked more into that, this looks good. So I'll go ahead and accept that. So yeah, so thanks JuggleTux for that. A little bit of clarity. Cool. So now I'll pull this stuff down. Oh, sorry, my voice is kind of messed up again. I was sick fairly recently, but we're good now. Yeah, so that's all the pull requests. I think we can just start hammering on stuff again. Reload the file. Boom. By the way, is it just me, or is this compiling a lot faster than I remember? Maybe I'm just used to some of the other projects I'm working on. I have this demo tool project that compiles so slow. Like, it's very, very poor. I'm really looking forward to when Rust gets incremental compilation, especially if Cargo starts using it by default. That would be lovely. Recognize physical address for 1C. I'm actually going to close this really quick. Let's see this. Oh, by the way, I just realized my face was covering that, so I'll pull that over. There we go. There's our unrecognized physical address. And that comes from my map. Yes, that's here. Yeah, here we're starting touch cart ROM. I think we're just reading it. And then 41C, I believe, was the display processor register stuff. Pretty sure that's what that was. So we'll go to x64 dev. Really cool repo. because that has some docs, including a memory map that's quite good that we want to look at. If I remember, I think it was for ops, and I believe it was one of these. Or map H. Bloop. Fatality 321, what language is that? Yeah, Daniel Collin answers with Rust. That is correct. Rust. I'm doing a lot of Rust these days. A lot of Rust. What was our address again? Yeah, so the DP command registers, it's going to be the display processor command registers. That's our rasterizer. And that's what we're hitting. So we're hitting one of these guys, the status reg. So I think what's happening here is it's probably just querying some status about this coprocessor. So we can probably just return some dummy data for now before we actually start that rasterizer. For now, we'll just go ahead and add some constants for these addresses. Put them here. Daniel Collin, Rust 1.1 was actually released 1 year ago tomorrow. It's really cool. Congratulations, Rust, tomorrow. That is really sick. Here I go, breaking the Rust formatting guidelines by aligning everything to the right. DPC. The Woot 2, Woot, you're back? Woot, I'm back. I say this every time, but I do want to start streaming more often. I just gotta get better at that. Carve out the time. Man, I'm losing my train of thought. DPC stage reg. That was between AI. I want to have that here. Okay. FPGA Nugget back in black. I do tend to wear black. Yeah, this is what we should get. So now we're getting errors that we didn't actually handle this address elsewhere in the code, which is exactly what we wanted to get. Don't you love when the compiler just tells you what to do? Not Mike Ryan. Good to see you again. Drew 2, thanks for the support. What was that, 53? Yeah, that's here. So here, we'll do read status reg from the RDP. Should work. And then writing, we'll also just map that out while we're here. This is before the AI. I like to line this kind of shit up. Okay, now we're gonna start hitting the fun stuff. RSP. That also need to do. Where's my RS? about that. Good. To do. So we'll just do this for now. Good. Not Mike Ryan. TJS is gonna make it today. Oh, that's kind of a bummer. How's he doing, by the way? I haven't talked to you guys in a while. Too long, in fact. Also, how was MGC? We don't need a constructor yet. Oh, he's back to school. What a dweeb. Oh, that's cool. Man, I feel like I was back in school yesterday. I rediscovered Monads. It's one of those concepts that, you know, being sort of a procedural programmer for so long, I always kind of had trouble wrapping my head around it. And a while ago, like I said, I did a bunch of F#, and so I kind of wrapped my head around the gist of it and like where they're useful and what they're for, and how to like read, you know, code that uses them. So like I was kind of comfortable seeing them, but wasn't comfortable writing them. And then yesterday, I just went super hard for like 6 hours on that shit, and it is. I think I really get it now. Now I can actually like think of why the type signatures are the way they are, and yeah, do proper stuff. Have I heard of Power Shovel on the PS1? I've heard that name. I'm just gonna Google this now so I don't forget. Leave that open in the tab. What about it? Is it just nuts? Yeah, so right now we'll just make this 0. See if it blows up. No, Mike Ryan says it's ridiculous in Japanese. That sounds like something I'm gonna love. I will check that out either after the stream or during a break. Okay, so now let's put this stuff together. Interconnect. I think I might remove all these supers here. Whoops. Bloop. I just think in general, using super like that should be avoided. It's just something I've thought about recently. Because it kind of, I guess, gives you harder coupling between the different modules and where they are on disk. And I don't really like that. Like if I split one of these modules into its own crate, then this wouldn't change. That's cool. Given this was correct anyway, and I think it was. Yeah, we have a RDP now. It does nothing, but we have it. That's all I'm going to do for that. Good to go. RSP is undefined? Yeah, because in RDP, we implemented some functions for the RSP, which is wrong. Yeah, write state is right. We didn't do that one. And then value is a U32, I guess. Yes, it was. I think... Yeah, I think I'll panic here, actually. And leave the to-do there. Doop, doop, doop. Okay. Boom. So now we're touching a different address. This part's almost zen, where you just like, the thing just hits all the addresses and you just go through these one by one. Which one was that? That was in, yeah, the RSP registers. RSP 40. Am I wrong, or is that in IMEM? Isn't that here? Oh, it's down here. Or 404 now, because it's 400. Is that not here? Oh, I think I only implemented IMEM and not DMEM. Is that the case? That's it. Nice. Cool. So now this is the data memory for the RSP. Do U8s again here. That's rad. Let's do the dmem length. Is that in memmap? Yeah. The same. Not my grind. You may have covered this before, but what kind of mic are you using? Apple heads or something nicer? I don't think it's this one. It might be. Or was that not a mic? No, I don't think it's that one. I think it's actually the onboard mic on the PC. I don't use anything more fancy than that. I think Soundflower, which is a bit odd. Should be using that one. I didn't just mute myself on accident, did I? Checking that? I don't think so. But actually, it's in my OBS settings, I think. Yeah, I'm also actually pretty impressed with it. Like, expected to sound quite shite. Yeah, it's a built-in mic on 2014 MacBook Pro. I do have a more proper mic. I do tutorial videos for my company, but yeah, it's big. It gets in the way. I don't want to use it for this. Apparently, I don't have to. This just starts here. Yeah, we'll bring this out as well. Pretty sure this is the same size. I believe 1000 hex is 4K. What? Yeah, that's 4K. Okay, now we'll map this stuff. should be it for that. And then here, yeah, we got my map in there. So dmem. Good. And then we'll probably have to do this part of the mapping as well, which is fine. Basically the same. Okay. And interconnect is going to need that. I'll let the compiler tell me. Boom. Here we do our DP, and right we'll have the same thing. Oh wait, no, that is the RSP. Well. Wait, what? It says 4 is less than or equal to the buffer length. Assertion failed. That's weird. Okay, now we need to start looking at some piff. So I'm just going to go ahead and pull all that stuff up real quick. Where's my MIPS? MIPS 4300. Big Indian. We'll copy lots of stuff. All right, where were we? Let's see, B8. All right, let me pull this over here. So we're here. Lol, B-bone bug. FPGA nugget plus dmem length minus 1. Am I missing something? That is correct. I don't think that's the issue here. Oh, it was. Ooh, why is that actually? Oh yeah, probably just because we hit the top of that address. But shouldn't that have? Oh yeah, of course, yeah, because it said the length. Yeah, it would have mapped the address above that to this. There you go. All right. Yeah, so now we get an unrecognized special opcode. That's a lot easier to deal with. CPU opcode. There's my product placement. Wow, 42 viewers. Thank you a lot, guys. Or thank you a lot, comrades, or something. I tweeted about that yesterday, like what is a good non-gender specific replacement to the term you guys. And it's actually really annoying that other than maybe y'all, or yuz, or yous, or however you say it, if you're like Irish. Thanks, Creelers, for that one. There's not a lot of options actually that covered that case specifically. I feel like, because you could say everyone, but that's not as specific as I want, right? You can't say you people, because then you just sound aggressive. Fellow meatbags was a fun suggestion. But then there was that didn't cover the case for someone that had a lot of plastic surgery. So I suggested fellow meat and or otherwise bags. Meat and otherwise bags. I don't know. You can't win. You can't win. You folks is pretty close. For some reason, I've never been into the word folks, but I might have to be. All right, let's actually look at this instruction here. Recognize special opcode. Is that out of the range of my face? Looks like it is. So let's go to our datasheet. Not that. There we go. Not Mike Ryan. Folks, friends, comrades, companions, carbon life forms. But then if you do carbon life forms, what about the British royal family? Okay, I'm sorry. I too am human. I love breathing oxygen. What was that from? What was that from? It was just like a tweet or something. I remember that. No, it was a Tumblr thing. It was like, yeah, would you fall in love with a robot? That's what it was. Oh, man, that's so funny. Oh, /r totally not robots. All right, guys. Tangent time. This might be my new favorite subreddit. This and YouTube haiku. YouTube haiku is so good. Sorry, guys. We're doing this. My Tinder girlfriend might be a robot. All right. No, I need to look at this later, but thank you for bringing that to my attention. I've also found great joy in the /r/ children falling over. Ted Cruz for humanpresident.com. I actually went to that. It doesn't exist. It should exist. If I remember correctly. Be one of these bad boys. We can also look at it. Let's see. Actually, I think we're executing out of something else now. I think we're executing out of yeah, loops out of the IMEM. Oh, so cool to see this stuff starting to come together. Not Mike Ryan, Ted Cruz for even president. It totally exists. Must have typed it. I'm gonna try again. If I Ashmadai, good to see you again. Nope, it redirects to Ted Cruz for president, which is like a nope. You know, calling that freaking time. Yeah, I know. Black Stealth. Thanks for watching. Yeah, not my grind. It's not working for me, and I really wish it were. Okay, apparently I've fat fingered it twice now. Good to see you again, QRAM. But I'm maintaining that that's just redirecting for Ted Cruz for president, or to tedcruzforpresident.com, which doesn't seem to have anything in it. Yeah, let's look at this code. Because I don't really know where in the disassembly to look. Oh, you need to do the www? Oh, this is so real. I'm broadcasting this. This is happening. 100% human candidate. I've been incubated for... Okay, you know what? I have seen this, actually. This is so good. I have over 42 years. I wish to shut down the space program and destroy all telescopes, abruptly and without explanation. Observing you. I once observed a child traversing on wheeled shoes. I will work tirelessly to find out what this technology is called, and demand the Earth children turn its schematics over to me forthwith. Oh, this is great. I must return to my hometown of T''Xs to slumber for an amount of time you would consider reasonable. Thank you, your support in skull sizes have been documented. This is amazing. This is really great. Data Colin, you can just output the hex codes into the assembly, right? Yes, I can. I can do that. Good point. Man, guys, tedcruzforhumanpresident.com. Don't forget the www. I am a total advocate of that. That is my kind of humor. I'm just pulling up another MIPS window so I don't have to paste the piff again. Oops. Is there such thing as fat mousing? Because that's what I'm doing. Ted Cruz is only one being, not several. What? Oh, man. That is beautiful. That is beautiful. Blaze. That was correct, right? Because I'm pretty sure I'm actually printing these out little and in, to be honest. So I think that this is actually what it is. Yeah. Let's go ahead and look at that. Then we'll know soon enough. Branch on less than likely or equal to 0. That probably makes sense. And our op. Ooh, wait a minute. Was this a special opcode then? This should have been special here and then something else. Unless I did decode this wrong and it was the MTLU thing. Let me look at that actually. Or multi-U. Is that an unsigned multiply? That would actually make sense if we're starting to hit some of the crypto stuff. Or the crypto stuff. Yeah, actually that's what it is. Cool. Yeah, unsigned multiply. By the way, guys, one of my all-time favorite songs. It's a Wave Racer remix of a song called Always by Panama. And it's just so good. Have to share that. Okay. Ted Cruz for human president. That's so good. Ohio, Yuki. Hello to you too, Yuki. Good morning, isn't Ohio? I guess I should say Irashay. Well, a bit annoying. Maybe you can print the address of the PIF ROM relative from 0. Also, then it would be easier to see where you are in the assembly. But would it? Because I believe we're executing out of like DMEM, so I actually don't think that would help. Or sorry, IMEM, the RSP's IMEM. I believe we're executing out of there, so I don't think printing the address relative to PIF would help in that case. If we're still running from the PIF, then that would make a difference. But Black Stealth's doing a Dreamcast simulator. Dude, if it's on GitHub, send me a link. I'd love to see that. This is my first 3D system emulator, so right there with you, man. Oh, cool. Glad to hear I inspired you. That's pretty cool. Yeah, seriously, send me the GitHub, or if it's public, send me that. I would love to see it. Basically, any, especially emulator-related repo people send me, I at least star. There's a lot of them, so I haven't, actually looked at, dug through a lot of them, but I want to keep an eye on them anyway. Okay, so this will decode the instruction for us. Sorry, window management is kind of special when you have to have certain ones on top, on the left. On the screen, you can't see. Yeah, so now we're in CPU. We need to actually emulate the opcode. I'll say I'll have to make a repo now. Yeah, dude, make this stuff public. It's cool. I like to make almost everything I do public, except demo scene stuff, just because there's that like air of competition that I think is really fun. The only reason I don't make it public is because I'm being competitive with other groups. Colin has a very basic debugging up and running in ProDBG now after the Rust rewrite, which is awesome. Really stoked to be able to write a plugin for that for this project, actually. And it actually might be pretty quick here that we'll start working on the command line debugger for this project, because we're going to start needing it, especially in cases now where it's like I need to look at kind of a disassembly of a few instructions around where the thing broke at. So I don't know how that's going to look though, so it'll probably be kind of annoying to write, but yeah, it was here. Since 64 cells, no debugger, highly frustrating. Really? How does TJ debug it then? Is it just like GDB? By the way, I mentioned this in my pre-stream, but extra special thanks to all you guys watching from Europe who are not watching Eurovision right now, or who are watching both. That's extra points. I totally did not realize that was this weekend. TJ sees the Matrix. Right. Red hair, blonde hair. I watched those movies again recently. They're still pretty fun. That and Hackers. God wouldn't be up this late. Yeah, sorry, Daniel Cullen. Links. I have links blocked. But if you can like undecorate it, I think I can post links. Tweet it at me or something. Those movies? You mean that movie? Dan and Beard. What do you think about Rust Up and Rust targeting Emscripten? I didn't realize that was a thing. Can't remember what Rust Up is either, actually. Oh, there's that tweet. This was the C API Daniel was trying to share, which I totally also want to share because I think ProDB is really cool. Well, I'm starring that, actually. Rust is a toolchain manager for Rust. I guess to help with cross compilation. And it's probably pretty cool. I haven't used it. In terms of Rust targeting Emscripten. So Emscripten's kind of a weird beast. I'm actually, what's cool about it though, the implications of it is that then you get Rust in the web, and that's good for the web. Like in your front ends as well as your back end. So I think that's cool. I mean, I'd have to look at it more to form a more proper opinion, but it's cool is probably what it's going to be anyway. Is it Neon Fuzz? Sorry, the font color got super green. But hi. In general, the web's getting a lot better languages. That's actually why I wanted to try Elm. I've had my eye on Elm for a long time, mostly because it was doing a lot of FRP stuff that was fairly interesting, and we were doing some stuff like that internally at work a couple years ago. And I just finally gave it a shot. They actually removed, or at least hid away a lot of the FRP stuff to kind of purify things. But my biggest gripes about Elm right now is that there's things that you expect to work in like Haskell, and they just aren't in that language. And some of it makes sense. Some of it's just like, really? I mean, I get that the language is not Elm. In fact, is not Haskell. I would actually categorize it somewhere between Haskell and F#, sort of linguistically, and JavaScript as well, because it has some structural typing that's similar to compile time duck typing. Anyway, it's cool, and I like working with it, but all it really makes me want to do actually is find a graphics library for Haskell and write stuff there, just because there's things in the language that I really miss. And in general, I have yet to see like a really big web app front end built in Elm, so I kind of have a feeling that its application is going to be limited. But it's a cool thing, so I advocate checking it out, but I don't know what I'd use it for other than... Actually, I think the best use case that I would use it for is to teach people functional programming, because it gives you a nice environment, like, to start playing with those ideas. So that's pretty cool. That's elm-lang.org if you guys want to check that out. I kind of like, actually one of the things I didn't like about Rust when coming to Rust was that it had a C-like syntax instead of a ML-like syntax. Because I think I mentioned this before, but one of the reasons why I picked up Rust is because I wanted to see what it would be like doing stuff like emulators that has to be super performant, and doing those in a functional language, so you could get the benefits of the functional approach, but then also do some really heavy transforms to try and make it really fast. Because I think there's a lot of room to do that, especially if you... actually do something like Elm, where, yeah, your top level code doesn't actually run the main loop or something. Like the main loop is external to your project, and then it can do some really cool optimizations, I think. Because the thing is, functional code just assumes less about its environment, so there's some advantages there. Anyway, I was thinking about designing a language that would run without GC, which is going to be the big performance thing. Yeah, big performance thing. So I was kind of playing around with language like that in my head, and Rust was the closest thing I found in terms of what it actually does. Like, especially the way it handles memory without GC and the safety guarantees that it gives you. There's a lot of stuff with like the borrow checker that I was thinking about at the time to design the memory management system. And I ended up just picking up Rust just because it did the trick. Even though it wasn't the same thing. Hey, Datsua, good to see you. Another fellow demo senior. Dan and Beard, Elm will be awesome if it just didn't target the front end. I think WebSockets are going to kill front end logic. I'm working on a library in Elixir that basically just describes how the front end seeds data to the back end and then handles all application state logic on the back end only. It's JavaScript for client specific non-application state changing logic. You could honestly, if you're gonna go that far, you could honestly just like stream data into your server and just stream out like HTML and just have a little JavaScript loop running changes. Might be some fun approach stuff there. Neon Fuzz, yeah, Rust memory management is good. It's honestly my favorite thing about Rust. That and just typing less than C++. Yeah, so there's an Elm rant. I might stream some of that Asteroids project I'm working on later. This is kind of fun. I don't think I'll do more in Elm though. After that project, I just want to give it a proper shot. Like I want to do, in that case, it's a game, but just like something that's kind of medium scale almost. Like I don't just want to be like, oh yeah, that's Asteroids. I want to do like a good Asteroids clone where like the Asteroids wrap properly. Like they're off one side of the screen, they come on the other. Like collisions are nice. Like particles, different kinds of game states, like game over and stuff. That's kind of how I want to get to that level with it to really kind of stretch the approach. But I have a feeling it's actually done fairly well. There's some things that are not as clean as I like, but again, most of that has to do with the fact that you don't have syntactic sugar over monads. Anyway, let's do this unsigned multiply. Neon Fuzz, I'm wondering what language I should make our game in. If by our you mean your team, then it's going to be whatever your team's happy with. Is it going to be a native game or like a web kind of thing? Or I haven't checked out Piston, which is like the it's a game engine in Rust. I haven't checked it out, but it looks like it's probably cool. But I think it doesn't handle stuff well, like if you need multiple windows or something, which would be really good actually for like debugging. In fact, when I was trying to set up my demo stuff, I ran into that. I ended up using Qt and hosting and GL window in there. Yeah, the other thing about Piston is immaturity, and like Conrod was the other one. It's a GUI library in Rust, which looks really promising, but again, very very immature. Just not ready yet, but projects I want to support anyway, because the guys behind them are pretty cool. They know their stuff. They're just enormous projects. Contents of general purpose register RS and the contents of general purpose register RT are multiplied, treating both operands as 32-bit unsigned values. An overflow exception never occurs. In 64-bit mode, the operands must be valid 32-bit sign extended values. Right. I can't remember what our Yeah, I think I just do the 32-bit unsigned multiply and then sign extend. Yeah, I've had both good and bad experiences with Rust. But the thing is, my experience with Rust keeps improving. That's something to be said. What I mean by that is like little things get better all the time. The standard library gets better. The borrow checker is getting better. We're gonna have conditional compilation soon. All things that you already have in C. Well, you don't have the borrow checker, but like, okay, only the really fast compilation is a huge advantage of C. Actually, I do have a couple projects where the Rust compile time is brutal, and that actually kind of hurts. Go might be cool. I haven't used it for games myself. I haven't really done anything in Go. It's a language that's on my list of languages to try, but I want to give it a proper go, as it were. So I'm just kind of holding on. I mean, there's no projects in my head where it's like, hey, Go would be perfect for that I'm doing. But I still just sit down and learn it anyway. Generally, that's also the case when I want to use like Haskell, but I just like Haskell as a language. I think it's nice. Partially because some of it's still a puzzle to me, and I think that's fun. But I have moved basically all of my C and C++ projects over to Rust, or a mix, because like I said, in some of my demo stuff, I have Rust where there's like the engine for the 3D engine, and like my data model for my editor, which is just like a scene graph and some stuff. All that's in Rust, and then I also have some editor state that's in Rust, which is like the undo stack commands that are undoable, like basically changes on the model. Like I guess like the core engine, data model, and editor state that's not entirely specific to the editor front end is all in Rust, and then I use Qt, and then I wrap that up in a C library, and then I have in Qt, in C++ and Qt, I have the actual window and everything. That'll fire up a GL context and actually instantiate the Rust context, and then there's a C API between, and that's actually quite all right. But again, whenever I have to change the Rust code, it's very slow to recompile, and whenever I change the C++ code, it's just super fast. We haven't hit that in this case or in this project, but in that project it definitely hurts. But I think actually incremental compilation is enough to solve that problem in that case. Because it takes a long time to recompile, but there's a lot of parts in that code base that I'm not touching most of the time, and I think that some of those are actually what's making it really slow. Like I have an asset manager thing that does a lot of stuff with generics and lifetimes that I think is actually the bottleneck in terms of compilation. Very tangential today. Oh well. Okay, so if I remember correctly, yeah, these are giving me U sizes, but I need them as U32s. Like, Stealth, what graphics backend do you want to use? If you're looking at Rust versus Go, it's probably going to be GL or some other engine that you want to plug into. I'm guessing in Neon Fuzz's case. In this emulator, I want to actually just do GL directly, but there's some reasons for that. The GL-RS bindings are really good in Rust. Although that is probably another thing that's hurting compilation time in the case of my project there. Just because they get regenerated basically every time you build. Probably just split those out into a separate crate, actually. I might do that. Yeah, Fuzz, that was me. Yeah, I know, but he asked it, I think, towards you. So that's kind of why I'm bringing that up. Okay, so apparently there's these low and high registers that I haven't heard of. Let's do that and see if we hit any instructions that might also mention that. In any case, our result is going to be rs times rt as that unsigned thing. And then we want to sign extend. That's correct, right? Because we need to cast through a sign type to get there. Yeah. And I've been putting those in parens like this. I don't think you have to, but that's what I've been doing. In Fuzz, were there multiple GL bindings? Last I checked, there were a few, and I didn't know what to use. Making sure you notice. Yeah, okay. The GL-RS bindings are really good if you just want raw GL. Like, they're quite good. And then there's like gluten and glium, but they just are like different things. Like one will give you a window, the other one actually, like glium gives you a full abstraction that like tries to make everything safe. And I opted not to use that in my projects just because I'm really familiar with GL, and I'm more comfortable just doing things the way that I know how and the way that I know I can make performant. But glium's probably really good. Gluten was nice because it just gives you a window. That's what you want. Then in like game dev, I would think the computational heavy stuff is going to be all graphics, and you're not going to be writing that in Go anyway. Otherwise, you're probably going to be IO blocked, not CPU cycles in that case. Go is a really good fit, although I much prefer Elixir. Yeah, I think you're probably right. Especially if it's like a 2D game. Like, Ryan, I want my RSP. I'll get there. Yeah. So then we self.write. Oh, okay, wait a minute. So the low and high register is actually something we need because that's actually where the result is going, I think. Oh, okay, wait a minute. We did model these. I forgot about that. Well, cool. Then we just load those up then. Yeah, I think I just remember being very confused about those previously. And here they are. You know, if it's a 2D game and you're comfortable with plotting pixels, if you want to use Rust, Daniel Collin maintains a Rust or a library called MiniFB, which I believe is like a C and C++ library, probably with a C API. So you can probably use that from anything, but he also has a specific Rust version that I've used that's quite good. But it just literally gives you like a frame buffer, and I think it now has some menu abstractions. And if that's all you need, that's all you need. But even if you're doing a 2D game, you probably want to do GPU accelerated stuff, if possible. That's MiniFB -RS for the Rust version, or just MiniFB. Fun if you want to do software rendering, and very, very easy to set up. Yeah, sorry, I have links blocked. I'll post the let me post the MiniFB thing. Oh, sorry, it's Rust underscore mini FB. That's my bad. This is the Rust version. And then there was the original version, which I haven't tried, but it's probably just as nice. But I mean, that's if you just want a pixel buffer, then there you go. But even today, I would still suggest if you can do GPU, do GPU. Just write a small 2D engine that way. And Colin says the Rust version is better. I'm inclined to assume that's correct. Yeah, so this is so these are literally just the low and high values. So we'll take res as U32 for reg low. Self.reg high is res shift right 32 bits as U32. That should be it, actually. In 64-bit, of course, these are sign extended and loaded. So we actually need to then sign extend these. So I'm going to put these as I32s instead, and then cast to U64 after that to get our sign extends. In fuzz, yeah, you want to be able to draw tile maps using tiles. Yeah. You want a simple GPU batcher for that. Did I say CPU? I meant GPU. Black Stealth, I noticed you have earphones in. What are you listening to? I have a playlist on my Spotify called Future Japan, and it's a playlist I curate. Just let me show you that real quick. Window management again. Bloop. We're going over here. Listening to that playlist. A lot of feature bass. A lot of some other stuff. So then there's these MF high and MF low. If either of the two preceding instructions is MF high or MF low, the execution results of these transfer instructions are undefined. Yeah. Worry about that later. Jay Shivink, did you see what Birkenfeld did in his Rust Endo fork? So I noticed that he got pretty far. I think he stopped a couple months ago. I think he stopped before I took my break, right? Where's the forks? Here. Yeah, so he stopped on the 5th, but I know he got a lot farther, but I've also been trying kind of not to look at it because I don't want to steal anything from it. Like I want this to be documenting the whole thing, so I don't want to take any of the ideas. But I think that's a really cool project. I think it's awesome that he's doing that. Cool. So I think this is good enough for this instruction, for now at least. Now we have a different unrecognized special opcode. Go ahead and see what that is. Okay, good, that's out of the way. Make sure this is correct endian. Isn't that what we just implemented? No. Why is this not showing the new stuff? Try that. Yeah, okay. MFLO. What is that? So from talking to these other N64 guys, my understanding of basically what the code is doing is just stupid nuts. Like it's trying to do some weird crypto things, but it's not like any actual crypto. It's just like twiddle all the bits. Yeah. So we're probably going to see a lot of that stuff. So this looks like we're just going to, move from that low register that we just wrote with the multiply into a different register. To ensure proper operation in the event of interruptions, the two instructions which follow an MFLO instruction may not be any of the instructions which modify the LO register. So that's, we're just going to assume that the code is correct in that sense. Dan Collins says, yeah, he uses his frame buffer stuff to fiddle around and try things out. That would be especially useful if you're doing Amiga stuff. The other thing I use it for is I did a Blitz Basic compiler. I found a bunch of code that I wrote when I was quite young. And I wrote a compiler for the language called Blitz Basic. And I used MiniFB for that as well. That worked great. Of course, I was still interpreting the code. Like I compiled it to an IR that was faster to interpret. But it's still interpreted, and that definitely shows in the speed of it. I'm considering actually trying to use LLVM from Rust. Do things that way. That might be fun. But I'll still probably run in process. Saves me from a lot of cross-platform woes. SLTU, I'll give you the same stuff. Plus more, I guess. So up to you. But I like MiniFB just because it's so minimal. But then again, you can get a pretty minimal SDL2 setup as well. That's a good option. Yeah, MFL. No, Opcode. Seems Australia will win Eurovision. Isn't that like a ripoff? Because not Europe? Does the US participate in Eurovision? There's no way. It is being broadcast here. Just make like a Globovision. Then Australia can win. Maybe they just confuse it with Austria again. Nyan Fuzz, thanks for joining us. See you later. Yes, this is trivial because this is just self.write reg GPR instructions rd. With the value, probably don't need that. Self.reg low. What? Oh yeah, because we borrow self to write here, but then we read self here, and the borrow is valid for this whole thing. So. Not a problem. Those are the kind of cases where the borrow checker is being probably a little bit too pedantic, but that's getting better. Jura, how's it going? Cool. How's the stream quality, by the way? Like, it still says it's acceptable. It usually tells me that it's excellent. So, has it been good? I want to look into that if it hasn't. Annoying that this doesn't keep the ending when I post new code. BAL. Is that branch always? It's probably one of those aliases. Is that what they're called? Aliases? Pseudo instructions? Most likely. Oh, it's a branch and link. Oh, hey, I just realized that this MIPS instruction reference, that's from University of Idaho. I'm from Idaho. Fancy. Ha, there's an instruction called BLT. This one had it, right? Branch link, here we go. So it's actually BGEZAL. Okay, so stream quality good? Thanks, guys. It's quite bad now and then. That's not good to hear. Valid pseudo instruction. So I've heard a little bit about this infamous BGEZAL, and what I think is going to happen here. I could be wrong, but this is what I understand, is that the part of the lockout mechanism on the N64 is going to write like some value to some address, and I believe that this was some seed or something that the PIF uses, the PIF in the CPU versus the PIF in the cartridge, and one of them like writes a seed to a certain memory address, and then BGEZAL is where most people get stuck apparently, because what happens here is that it's going to start looping like an infinite loop because that seed was never written to memory. That's my understanding of that, and I think this may be where that happens. We're going to implement this instruction and see if it just loops forever, and if that's the case, then that's what we're going to deal with. Yeah, so that's BGEZAL is the point. Branch of greater than or equal to 0 and link. And that would make sense if it was just branch always. Because you could just, load RS with a 0 reg, I guess. Now, Ryan, for some context about what Ferris is talking about, the CPU needs to write some data to the PIF to kick off the copy protection sequence. I'm guessing what happens here is the CPU writes this into PIF RAM, which is mapped to the global address space. But in my case, it didn't write that. So the code is trying to lock me out. Trying to not execute my stuff. Sick. Seven#9, good to see you again. There's a path, so memory write should be implemented first for this to work. It's not like necessarily a memory write; it's a specific memory write, like to a certain address. I'm not sure the details. I just know it's part of the lockup mechanism, so I'll probably have to dig through some documents about this. But yeah, that one specific write will probably need to be implemented before we can get out of this loop, is what I foresee happens. Just from talking to guys who know a lot more about this than me. So hitting all the traps. Yeah, so let's go ahead and implement this. Reg immediate, is this a decoding scheme that we've hit before? I don't think it is, actually. Greeliz's comment is awesome. I don't feel like explaining it because there's some context, but that's not what that was. That's in a different Slack group that I only open on weekdays. It's pretty funny. Zapeth, you can probably fake the memory write and just return the expected memory value from the memory read. That's a good point, actually. You just do that, probably. Since you expect to only hit the BGEZAL during this boot sequence, why not print out some debug info like PC and maybe some reg values? Yeah, that's probably a good idea. I'll do decoding first, and then I'll probably do that. Because again, I want to do the I want to do a little debugger like that anyway. At least when it gets stuck. We'll see. I'll do it in that instructions implementation just for now. Branch address is calculated from the sum of the addresses of the instruction in the delay slot and the 16-bit offset. Shifted 2 bits left than sign extended. So we've, I believe, branch and branch likely. Is that different from branch and link? Otherwise, that R31 gets set. Patreon. I forgot about Patreon. So that was actually something that I would that I do want to set up, but I feel bad like putting one of those up when I don't even stream very often. So that's kind of why I haven't. Maybe at some point I want to do like branding, so look like a proper channel. But the biggest thing that I need to do in that case is just stream more. Like, so far, I've kind of succeeded in making this fairly low effort for myself, which is really good. And I want to keep it that way, because otherwise I won't do it. But, yeah. I don't know, I might set up a Patreon anyway. I do a lot of projects anyway. Even if I'm not streaming. Back South Guild trip. Not Mike Ryan, my Patreon is buying you beer. That's very true. We should do that again. Yeah, so this is... It's calculated from some of the address, the instruction, and the delay slot, and the 16-bit offset shifted 2 bits left and sign extended. So I'm pretty sure that's exactly what happens here. Unconditionally, the address of the instruction next to the delay slot. Yeah, so that's going to be the one after the delay slot. Is stored in link register. So what I'm going to do is my typical refactoring technique here. Yeah, the Patreon, if I set one up, it would be like to fund this kind of thing. Would be to fund the stream. I mean, I'm just not spending enough hours a week doing this to warrant that. I feel like maybe at some point. Yeah, and then it just gives you a warning about how you shouldn't be using R31 as your general purpose register because it's going to be destroyed. Going to mess some stuff up. But it's valid, so you can't execute it. This one's bool. Yeah, so that's a little bit different actually, because it's right. So the other thing is that this other side here, yeah, we're gonna degeneralize this a bit. Krillers, yeah, I'm not doing a Patreon for an N64 MU. if I do, it's for the channel. Like I want to, yeah. If I make this a more proper thing and do other stuff as well, that's what it'll be for. Okay, you know what? I'm just gonna actually take all this, because I don't know if this logic will actually be reused in a more general context later. Wait, did I even do decoding? I don't think I did. Oops, Opcode. We'll trade it. We'll trade beer prices for offers open to all. And he's good for it too. Mike Ryan is good for that N64 beer. Yes, we're gonna want to do. You're gonna see my Emacs getting pretty bouncy in a second. I'll just do this. Funny chat. Yes, and then I think I had this in instruction. Yeah, I had these. Do the same thing. And these probably also don't need to be inlines. I might remove those, but for now we'll just leave them. Pretty sure I said that before. Black Stealth. Dreamcast ROMs are bigger. There's just a lot I wish I could force Rust to do, so that's why I stopped using it. It's funny. Just copying the format from above. My favorite thing about going out for beers with Mike Ryan is that he only asks when I'm streaming now, and I think that that's really funny. But to be fair, I never ask because I'm really, really, really bad at keeping in touch with people. Really bad at that. So in that sense, he's got me beat. How neat is that? And we'll do the same thing here. He's trying to make you associate beer with streaming, says Creelers. Smart. Smart. You can zoom, there was a typo on the last method. Unwrap. Yes, there was, thank you. I say this every time, but the best part of the stream is this live compilation I have going on in the background that's actually made up of a lot of people. Regim up? Regim up. Regim up is my Korean name. Yeah, and then we're gonna have wait a minute. We can still use this. No, because of this. Yeah, let's just copy this in here for now. Let's see. Ezeal is almost certainly just one character swap away from being a Final Fantasy boss. And Creelers is on fire. Maybe literally, because I think he's pretty drunk. Black Stealth, listening to some, I guess, PlayStation soundtracks, PS2. I can't remember when. Or was it N64 at that point? I don't know, Dreamcast. I don't know timelines. Okay, so unconditionally, the link address is always stored in R31. Good to know. In the first cycle, even. Or it's T and T+1. I don't know if T's are actually cycles, but apparently it happens before the condition. Oh, no, wait a minute, because it loads the condition in that first time step as well. So it actually could be fine to use R31 for this, just you can't really use it after. is taken. Yeah, it's going to be self.read reg GPR. Oh no, we already have that in RS. Done. Isn't it greater than or equal to 0? I feel like there's a bug in this data sheet. The way it interprets the condition. Because you branch if it's greater than or equal to 0. Yes, this logic changes a bit. SNES corner area, nice. I quite often listen to the Chrono Trigger soundtrack, but that's also because I quite often play Chrono Trigger. Love that game. The Kirby Superstar, another fantastic soundtrack. That's just like really, really good. What was this? So that's correct. And then we have the delay slot, and then we have the link address, which is going to be the PC after the delay slot. So that's going to be delay slot PC plus 4. So we always assign that. So it's going to be self-write reg GPR 31 link address. Is PC 64-bit? Yeah. Okay, then that's good. Accent offset stuff 2 wrapping add. And then I guess I'm missing here the semantics of the delay slot again. I assume it's going to be the same as this. I assume it's going to be you hit the delay slot when you branch, because it's not a likely instruction. We're not returning anything in this case. Right? Is that correct? Yeah, okay. It says with a delay of 1 instruction. Equal to or larger than 0. When would it not be those things? Oh, it does say that it's here. the 31 bits of this. Good to know. Or no, because that's just the different signs here. Because does that mean it's going to be signed? It would have to be, right? If it's going to compare to greater than or equal to 0. I feel like that's correct. Oh yeah, that is what it's taking. It's taking the 31st bit and just comparing it to 0. Then, okay. Let's, this does that. This will be okay if we do that. Except that it's wrong in the 32-bit version. But it's not, because these are assumed to be sign extended. So this would be the same. I think we're correct. Okay, I think that's good then for the logic. So then the only things that was actually different about this versus the other branch, RS and RT were a little different. And the fact that it wrote the delay slot, or it wrote the link address. I hate Boolean parameters. I'm considering adding a right link here, and then also yeah, because this would still work. So the only difference here is that we calculate the link address and we write it. Everything else is fine. Okay, you know what? I think I'm going to do it now, and then if I decide to refactor later, I can. I think that that's fine if I do it that way. This is what I hate. What does that false mean? I don't know. Well, I do because I just wrote it, but my function now does two different things. But I think we'll be right here. So the other thing that does, though, is it does... Not really. It only moves this one out there. Depending on how smart the compiler is, it can know that these are only used in here. Except for it'll be used... I think this will be okay. Right? And so then this becomes this. It's going to be self.branch. Where we do want to write the link. And then we have RS and then the ignored RT. RS as I64 is greater than or equal to 0. Right? Pop. So I think that's correct. Oh no, we need the instruction first. Why? Why did we need the instruction? Oh yeah, so it can actually unwrap RS and RT. That's fine. That's fine. Not used to putting commas. Actually, that was fine with that line length. Not used to putting commas between my arguments. Writing too much Elm and Haskell lately. So I think that's okay. And then the compiler will complain about all of our branch instructions. There's only a couple other calls, which are right here actually. All right, unrecognized special opcode is all zeros. That seems wrong. Is that valid MIPS? That is the question. Frankly, I wouldn't put it past MIPS. So it's a no-op. Ew. That could just be a no-op in the delay slot, but it's like kind of weird that we haven't seen that before, isn't it? Let me search for a no-op in here. Oh, there's a no-op. Did we have an add.iu and a BAL before this? Add.iu, LUI, add.iu? Why didn't we hit the BAL? Oh, because we're in the middle of it right now. And then it hit this because it's executing the delay. This makes sense, actually. Okay. Dan Collin, that is likely the case. Jura says NOP is a pseudo op 2. I think this is an SLL. Let's look at that actually, because we knew it was a opcode. Let's just search SLL first. That's probably correct. Shift left logical special. Yeah, that's exactly what that is. Thanks, Jura. Good stuff. So let's go back to op. Nice. Shifted left by SA bits, inserting zeros in lower order bits. The result is stored in general purpose register RD. And then we also get sign extending. This instruction could generate a 64-bit value that sign extends a 32-bit value. Yeah, so we're correct if we basically take what we have for SRL and just swap the shift, I think. Because that was also a logical shift, we're just inserting zeros. Which is what we'll get here. Caution, if the shift value of this instruction is 0, the assembler may treat this instruction as a no-op. When using this instruction for sign extension, check the specifications of the assembler. Aha. Let me think about this again. Because that would just make sense. If everything's 0, then RT and RD are all 0, so it's going to write to the 0 register too, which just throws it away. Shift left 0 with 0. Yeah, I think looks like a no-op to me. And now we should be in an infinite loop. No, we're not. We got a different op. So I guess that BGEZAL was not the one we're looking for. Or it is. And we're hitting it in a second. Exclusive OR. Black Stealth. Yeah, the time here is 4 o'clock. I'm in the Bay Area. Black Stealth. When should we expect graphics processor programming? Honestly, no idea. If Frankly, I have no idea. I don't have enough overview. I'm just kind of taking things as they come. Maybe soon, probably not soon. We'll find out. Cruel's endiness is dumb. Is dumb. I think everything should have been little endian, but that's just me. Oh, you said little endian has outlived its usefulness. You're probably right, though, because my argument for having things little endian was that it was convenient for 8-bit processors, so yeah, you're probably right. And then big endian is easier to read. For humans. I'm actually going to take a tiny break. I've already been at this for 2 hours, but it's mostly been rants. Yeah, I'm just going to take a break. I'll be back in 5. Boom, we're back. I believe my connection dropped sometime during that break. Went to the bathroom, came back, it was down. And yeah, now it should be good. Now my stream configuration quality is saying excellent. Restarted a couple pieces of hardware. Now it seems to be okay. So just sorry guys if it drops. I don't think it will, but yeah. Okay, there's Jake at least play cute music while he's AFK. I've been considering that actually. At least some of the stream friendly stuff. Because I believe it's Monster Cat has some agreements with Twitch that you're allowed to stream some of that music as long as you have their bot in your channel and as long as you yeah, and then it works with VOD. But I don't think you can upload to YouTube after you do that. So that's one of the reasons I haven't done it. So that way I don't even have to edit anything. I just dump to YouTube. Speaking of Shiba, there's this, man, stupid dog videos have been so in my life. And I need to find this one. It's a tweet I liked and shared with everyone. I think it's so funny. And I like a lot of tweets. This is worth finding. You guys are gonna wait. Found it. I'm just gonna leave that there. You're welcome. Anyway. Let's get back to this stuff. And there went literally half my viewers. That's pretty funny. Yeah, this is where we had XOR. Let's go ahead and take a look at that. Is that unrecognized special op? Yes, so this is good. I need to have a bot that responds to people asking what language this is. I'm not even gonna try to do all those letters. It's Rust. It's Rust. Wait, we're talking about the funny guy. Funny guy. Yeah, so this is one of the simplest ones we've hit. I believe exclusive or is the same symbol as in like C. Let's find out. more fun crypto-y looking things. Or wannabe crypto-y looking things. Subu! I believe that's going to be unsigned subtraction. But Subu! It's way more fun to say. Shots fired from Creelers. Yet that still pretty accurately sums up his Twitter these days. Steve Klabnik's Twitter, I mean. Because if you were to sum up Creelers' Twitter, it would be joy. Maybe crust language needs to be made. I could do that. I could make crust. It's going to look like Haskell, but it's going to have C's memory model. Or maybe it'll look like Fortran and just be Fortran. I think that would be crust. Crustlang, yeah. Using language shipped off the periphery of other better languages. I still follow Steve. I haven't formulated my own opinions on those topics, so I don't really know what to say about that, but I still follow him. You get more Rust stuff. Crazy, just put in some lints that turn to errors when you use tagged unions or generics. It wraps your code in a huge unsafe block and you're done. That would indeed be crustlang. That's pretty funny. Yeah. So it's just a 32-bit subtraction with a sign extend again. The only difference is that between this and sub is that this one won't cause an overflow exception. But for our purposes, it's just the same. So let's actually let's do this. Honestly, I would love a C with algebraic data types. If you had tagged unions in C, that would make me happy. And of course, pattern matching to go along with it. Because it's those two features together that are nice, not one in isolation. Would not mind having those in C, C++. Yeah. Excuse me. It's literally But won't I get an overflow exception? What did I have to do to not do that in Rust? I can't remember. Was it wrapping add? It was, wasn't it? So that's going to be the same regardless of whether it overflows or not. So I can do the sign extension here, and it should be fine. Crazy says, did you consider using a wrapping U32 instead of calling the wrapping methods manually? So I could be wrong, but when I did my SNES audio unit emulator, I remember I tried switching to the wrapping variants of the integers instead of the integers. And I think because then all the other values that I had to pull in, I had to wrap in wrapping types first to be able to like do basic arithmetic on them. And so I remember it being really annoying, actually. Like, it was a big pain point, especially because I was porting that from C++. So I think that's generally why I've stayed away from it in this case. But I just remember that being really annoying. Really annoying. And so one of the things that would fix that, though, is just overloads. So if you have a wrapping U32, you should just be able to add a U32. But then that's kind of weird as well. Like, just because one of your operands was in the wrapping world, you get both wrapping. I guess it's the same as doing like float int, add, not in Rust, because Rust won't let you do that. But yeah, you just get stuff automatically casted in something like C. But that's kind of where the discussion was that they weren't sure the implications of doing that, and so that's why all those overloads haven't been put in. I can't remember where I saw that. It was on the Rust internals forum, I think. Creators was talking about Rust syntax and how it's great. I agree. Like the syntax feels like it's together. It feels cohesive, and it feels like it only has the syntax it needs to make the features it has ergonomic. Until you have to specify lifetimes, then it's just gross looking. But usually it's not that bad. You don't have to do that very often. When you do, it's relatively straightforward most of the time. I think in my experience, that's been the case. George's asking what my opcode match compiles to. Yeah, it should be a jump table. In fact, it should be a couple nested jump tables in this case, but it should be fine. Crazy saying, yeah, it's up to the compiler, but I'm guessing that's what it'll end up as. We could check some disassembly for that later, but I'm not gonna until we need to start thinking about performance, which is a long ways from now. I mean, I'll think about it in the small, but you know what I mean. Until that's a bottleneck, I don't want to dig down there. I'm agreeing with everything Creelers is saying about Rust syntax. It's easier for me to say that than to say all the things that I agree with. Or to read all of his messages out loud. Oh, is this going to be something with high? Move from high, yeah. So is this the exact same thing that we had with MFL? Probably. By the way, have you guys seen the show Peep Show? I recently discovered that. Oh my gosh. Oh, that's so good. I love cringe humor, and that is a great show. It's on Netflix, by the way. So if you got Netflix, watch that. It is so funny. So funny. And Mitchell and Webb, like, so I also watched the Mitchell and Webb look, and I didn't like the Webb look as much, but to be fair, that's because the CEO of my company quotes that like every other sentence, so I might just be sick of it, because it is definitely has its moments, especially in Number Wang where they rotate the board. So good. But yeah, man, Peep Show. That is so funny. Could just make his own language so he can write a compiler just to learn about that. Like the balance of how, I guess, different features both syntactically and in your standard library play with each other. That is the interesting part of doing a programming language. It's definitely the interesting part. Okay, we hit another one. We're just blasting through instructions today. Blasting and ranting, that's my stream. So now we're doing add you, which is the add unsigned. Dad you. Peep Show is so hard to watch. It's too real. I agree, and that's why I think it's so funny. It's well, it is and it isn't. Like, it's presented in a way that makes it feel super real, but all the characters are just dipshits, and that's why everything happens. Same with Curb Your Enthusiasm. Like, none of that would happen to real people, but it makes it so real the way it's presented, and it's so funny. So funny. So in regards to like garbage collection or reference counting, like Rust, when you're talking about language design, one of the things that I thought about when using Elm recently was so normally when I like design programming languages, I've historically done it on .NET just because that's where I was comfortable, and I could get all the way down to .NET bytecode fairly easily. I've considered using LLVM as well. I just don't really have experience with that. And if I do play with LLVM, it'll probably be from Rust. But what I've been thinking about recently is to start using JavaScript actually as a backend, especially for playing stuff out, just because it's like how quickly can you actually get running code. I mean, yeah, like I don't like working with JavaScript, and it has a lot of pain points, but like you could get to running code so fast. Hey, Spoon's back. Good to see you, man. Crazy, what about WASM? I don't know what that is. Curb Your Enthusiasm is pretty easy to predict how the episode plays out. Peeps not so much. That's so true. Scare, that's because you were too busy watching Eurovision, probably. Oh yeah, WebAssembly, of course. Yeah, so I actually know what WebAssembly is, but I don't know. I haven't actually tried it or like looked at like what instructions it has, right? Oh, you define an AST. Okay. So that would kind of be in the same vein. Like, I'm not looking for web specific technologies, but it's just like things where it's so easy to get to another language, right? For yeah. XM player. Wow, that is old. Because they're saying right now is compiler transpiles to its own style of C++. Yeah, that's fine. Wait, since I CVA doing native code gen and LLVM is cheating? I misunderstand what you mean. It should be easier to compile in WASM. See, then it's cool because you get something maybe a little more performant, but is it easier to generate code for than JavaScript? Because that's what I'm looking for. I'm not looking at like, oh, I can support web, because I don't give a shit about that. But I'm thinking more like, how quickly can I get a backend and like start running code and doing tests to play with language features, right? And that's where if there's something better than JavaScript, I'd love to know about it for that. Like I said, historically I've used just .NET with reflection emit just because I know it. But even then, I think JavaScript can be faster in terms of me being able to generate code. Like I'm talking about my not machine performance, but my how quickly I can prototype stuff. And that's basic compiler I was talking about. I did that in Rust, and that was pretty good. But I think one could do better. I mean, and that would still interpret things. That's the other part. That didn't actually do code gen, so it didn't even solve that problem. Oh yeah, because just saying Elevate was cheating because he's writing a compiler to learn it because he finds that really interesting. I did one compiler maybe where I generated x86, and it was, I think it was a brainfuck compiler. Because I mean, other than that, like, I don't feel like you have to do. I don't know. You can do it once. I think it's fun. I think it's cool. But I did a lot of handwriting assembler with like demo scene stuff. And I kind of just I feel comfortable enough in that space that I don't really want to do any more work in there. But I would definitely understand that if you want to do that to learn about it, that's pretty cool. That's pretty cool. I'm trying to order these like in the order the bit patterns are. And I got that wrong in that sense. Is this a special one? Yeah. No, that's correct. Dana Collin can recommend Engineering or Compiler Second Edition. I haven't heard of that one. I'll check that one out. As long as it's not the Dragon Book, which is good on its own merits, but only goes so far. Kreis and Creelers, sorry about the link stuff. You could tweet them to me. I can paste them. The thing about LLVM is that it does code gen, and it is good. Like, you can just use it, and you have native code. that's the thing. You can also make a lot of different kinds of front ends for all the backends they support. Just saves a lot of time. But then you have to learn it. So funny getting those tweets. ast.run is the WebAssembly link. That's pretty cool. Retweet some stuff. So this was the link Kreis was trying to share. It's textual representation of the WebAssembly AST. So I'm just going to leave that open for myself to look at later. That looks pretty cool. Pretty interesting. Oh crap, I just closed the link. Mike Ryan, if you're still there, what was that PS1 game? I forgot, like Shovel something? I accidentally closed the tab. And this was the link Creelers was trying to share. Power Shovel, yes. I'm gonna check that out after the stream. I don't want to forget. Yeah, the AST and parse tools. Then I'm like half and half, because I like being able to express grammar in a sort of formal way, because I think that you get a lot of compatibility with other people as well, and you analyze your language in a way that or your grammar in a way that I feel like you should be analyzing a grammar. Like when you just do recursive descent parsing, I feel like excuse me, I feel like you almost hit more corner cases, just because you're not thinking about a grammar in the same way. But it also works really well, and when you do recursive descent, because you have full compile or full control over what the parser is doing, you can make really good errors very easily. Oh, Creators, do you use fparsec? Because it's so good. I tried in the Rust compiler that I wrote, or the basic compiler I wrote in Rust. I used nom for the parser, and that had some really good and really bad things about it. Like it was I don't know. It was generally pretty nice the way you were able to build grammars, and I like having grammars available as macros because you can get those generated compile time without leaving your language, even though you kind of do because you sort of jump into that macro DSL. But I found the errors it was producing wasn't that great, but I think you can augment that. I think it has features for that. I think I just didn't use them. And there were some details I found that were kind of painful, like if your file ended with an optional thing, but you hit end of file before you hit the optional thing, it would say, oh, my input's incomplete because I don't know if the optional thing was there, even though you could have known because there was nothing else. But I guess if you go deep down into the context of the grammar, that's like a special case. Really low level and the higher level stuff probably has to assume that there might be other things. I can't remember the details, but stuff like that. Yes, yeah, fparsec's really cool. I was doing a F# compiler to play with some emulator stuff, which is the stuff that I'm supposed to email you about, Graylers. And I use fparsec for that. I use it for a couple other things too. Fparsec, by the way, for those of you guys who don't get the context, it's an F# parser combinator library. So if you're familiar with Haskell, it's basically parsec, but F#. That said, I may be wrong about that because I haven't actually used parsec, but I want to. Yeah, so this is correct, I think. More opcodes. I'm getting hungry. Whoops. Not even thinking. I'm really getting hungry, apparently. SLTU. Blah. SLTU. Which assembly language is best assembly language? They all suck, dude. Agreed. Actually, though, like the .NET bytecode at least was actually pretty nice. I assume the Java bytecode was similar, but probably a little bit worse because that's generally the case. Oh, Skag got an S emulator to the point where he has a test realm started doing undocumented opcodes. Nice, that's pretty cool. The other thing too is that, like, if I want to play with compilers, I can just do it, F# on mono, but then that's not that comfortable either. I just think as a backend, JavaScript kind of makes a lot of sense, especially if you're prototyping stuff. I've yet to come up with something I think would be better for that purpose. Oh, yeah. One of the reasons why I would actually like to have a functional language for doing emulators in is you could do proper like step debugging, not only per cycle, but per like in the middle of cycles, right? Because the whole thing is just like a pipeline of CPU states or whole system states really, and so you can, if you did enough code transforms in your language, right, which is why I want to do a compiler for this, you could get it so that it would probably run fast, right? It would probably still run, as fast as its mutable equivalent. Maybe not, but I feel like it's possible to do that with some restrictions, which I'm thinking about. But then the advantage is that you could also swap back to the functional implementation whenever you wanted. And so you could just all of a sudden, like I'm running my emulator and I know that like there's a bug coming up or something, right? You could just say, hey, run this in the mode where it's actually taking intermediate states and then actually store those, and you can have a debugger where you can watch the individual states of the entire system, right? And that's something that would be, if you're doing a mutable emulator, it's hard to just add those as save states and error prone. Whereas if you did a functional emulator, you would automatically have that available. So I would actually like a functional language for that. But then the problem there is that it has to be very fast. So I think you'd have to do some pretty complex transforms on it to basically make it not functional in the end. With, again, either garbage collection or something like Rust, which is, again, why I picked up Rust in the first place. Set on less than unsigned. Jesus. Okay. What a weird instruction. Daniel Collin, my plan is to support that in ProDBG and emulators to store a state for each instruction that allow you to playback time I learn. Yeah, see, like it's something that you could fit an emulator with. Like you could just have a save state function. So every time you run it's the memento pattern if you're familiar with the OOP term for it. So you can do that, but again, you get that for free if you had written it in a functional language like this, and that's kind of the advantage there. It would be very easy to make tests, those kind of things. For tricky bits of hardware. So I think there might be something to that, but I don't know. I need to play with it. The downside about writing a function, Kuro Sensei, an emulator for what? Just in general, just like an idea that I had. Kuro's saying, yeah, like in functional language, you just have that stuff automatically. But the downside, of course, is that you probably also have GC. You probably also have these other things that are gonna make it too slow to like play games, or you know what I mean. So you need to solve that problem in your compiler as well. But I also like functional languages just because they make less assumptions about the way in which things execute. So it allows a compiler to be able to move things around more. Whether or not that's still, a solvable problem in that case, it's debatable, but that's why I want to play with it. Daniel Collin, it's nice stuff until it's not. See, that's very true. The way you handle state's a bit weird, and you need to know what monads are for a lot of things. You need specialized syntax to start making those actually bearable. That's just, You have stuff like tail calls that you have to worry about all of a sudden. I feel like imperative languages are, in a lot of ways, good for emulators just because you're typically emulating systems that work a lot like your execution model also works. So in a way, you end up with something ergonomic just because evidently they both act the same way. Like I feel like it'd be harder to write like a NES emulator. Like it would be more obvious how to write a NES emulator in C than it would be like to how you would do it in Haskell or something. Yeah, because it's saying F# is so nice. Everyone's doing C#. Just move to that. Frankly, I agree. I really, really like F#. The reason I got into it was because I was very familiar with .NET. It was just a very natural way to get into functional programming. And of course, it has strict evaluation, so you still have like the whole mutable stuff. If you want to write F# like C#, you can still do that, and you just end up writing less characters. I actually didn't know that C#7 wouldn't have pattern matching. I kind of assumed that would be one of the things it would have. I really have not kept an eye on that, mostly since I'm not on Windows most of the time anymore. Okay. RSP&D, yep. Value is, yep. Oh, we don't actually need to do the subtraction. Done. Oops. I don't even know what the hotkey is, but I hit it all the time. Crazy, they just removed it recently. That's actually interesting. Do you know why? I'm sure they would have said something about it. About why. What's the guy's name? Heisberg? Nah, he's not the one I'm thinking of. I'm thinking of a different Danish guy that works on C#. But I do find that surprising they won't have pattern matching. I wonder if it's just because like a lot of the libraries don't have support for that kind of stuff. So it just would be kind of weird. It looked like you have two different languages. SLV. Shift left logical variable. This feels like a really useless instruction. Crazy says, I think they just postponed it because they didn't have tagged unions and stuff yet, so it was super unfinished and way too early to stabilize. Yeah, that makes a lot of sense. Like one of the reasons why Elm doesn't have do notation is because it actually can't describe higher order types, which means it can't describe what a monad is, which means it can't have do notation. And I feel like not having pattern matching because you don't have tagged unions makes perfect sense. Like that is the feature that makes you really want pattern matching. You don't need pattern matching unless you're doing destructuring. Yeah. Move away 00. Tag unions are basically a prerequisite for any new language I want to use anymore. Dude, me too. Me too. Because I was saying I didn't like the syntax for it anyways. A weird mix of F# and Scala. I like F# a lot more than C#. But I'm really not using much of either these days just because I'm on Mac. And I'm not touching Xamarin Studio. If he's just using functions as parameters. That's funny. I think a lot of what makes functional languages really nice though is that they have a lot of these features that you still could have. Like tag unions and pattern matching came from functional languages, I think, but you can still have them in imperative languages, like in Rust. But I think that's a lot of what makes functional programming nice, are those kind of features, and that you have typically lighter syntax. So it's things that aren't necessarily the functional bits that are a big part of why those languages are appealing, at least to me. He's like, yeah, pattern matching just switched on steroids. Blub language talk. That sounds familiar, but I don't think I'm familiar. So this really just felt like a shift left. This instruction here. Yes, that's not correct. I think that's why it's called variable. Shifted by. I think that's correct, and then sign extend. Yeah. And then that's written to RD. Yeah, I think that's correct. Is it just me, or is there just like a lot more .NET shops in Europe than there are over here? QRAM, I think that's what I wrote, except I have some like sign extends and only taking certain bits of stuff. I think that is what this is saying. I think that's correct. So many special opcodes. But this is nice because we're just blasting through these. Oh, did it again. Got to paste the opcode into the datasheet. SRLV. Someone misspelled silver. I don't think the stream's down. I haven't dropped any frames. Sorry though if that had a glitch. Creators, how do I get a job in the USA as a 22-year-old so I can make lots of money? Move out here, do web. Unfortunately. like get an ego and do web and move to the valley and you will be a successful 22-year-old. That is my experience from living in the Bay Area. If the stream is working, it hasn't dropped for, like, if one person says the stream hasn't dropped, that's actually fine, because that's good, because I'm recording the whole thing, so I'm worried that I start. Yeah, I don't know. Never mind. SRLB. I don't know what I'm thinking. Oh wait, who missed everything since the break? Oh man, sorry if that happened. Oh, that'd be a bummer. I mean, it is recorded, like, but that's still a bummer. Oh, sorry, dude. Yeah, when I went on the break, it went down for like 5 minutes, but I did fix it on my end. So you'll get the recording, but yeah, sorry about that. Yeah, sorry, both of you guys. So I actually don't know if just changing this to a shift right is correct. Because it mentions the sign extended 32-bit value. It probably just shifts the whole thing though. Because those bits were probably 0 unless it was like a negative number in 64-bit mode, and then. But you really should only insert zeros, but then it says here though. Yeah, here it is. You always do it as a 32-bit value there, right? Okay. So we do that then. Or we can make this nicer. Let's. I think that's correct, because then we always do the shift as unsigned 32s, and that will insert the zeros at the end, and then we sign extend that from the 32-bit value to the 64-bit value. That feels pretty good. Oh, there was a big loop. I'm gonna run that again. That was exciting. Nice. And then we hit another special opcode. Special instruction. And that's and. Surprised we haven't gotten to and. But I was also surprised we didn't get to no op. Oh, good. Searching for and in a data sheet is a good idea. Can I search and instruction? I don't think so. We did have some bits though. Or let's look for or, which is another one that's fun. SRLB. Let's go down there. And then these were maybe alphabetical. Looks like it. Can probably search for one closer to and, but I don't really care. We'll get there. Now Rust is oh yeah, Jiro was saying. Full graph execute instruction from Git. Oh, that's cool. Ended up not being a jump table after all, actually. But it's probably nothing too bad. The thing is that my understanding is that the Rust compiler really tries to look like C++ according to LLVM. And the reason why is because, you know, most of the people that are working on LLVM are optimizing things like C++. And so I'd imagine that something like the pattern matching that they're doing is gonna end up being pretty similar to whatever a switch would get compiled to. But I would understand that if it's not a jump table, because we have a lot of holes in the definition, like we're missing a lot of bit patterns. So if it's not a jump table, that's actually probably why. That tends to be the case. See you, Creelers. Thanks for joining. That said, I don't really know. I haven't studied the output from the Rust compiler very much, so it might do a terrible job at doing that, at trying to look like C, but I don't know. I know that that's the goal. I know that that's the idea. Yeah, so this is just straight up and. Oh, wait. I think I messed up some of these. Yeah, Drew, the name mangling is definitely bad. But that is kind of the point. It's usually pretty bad. But here's where I think I messed up in add U and sub U. It's the contents of the register that we're adding, and I didn't pull these out completely. So self, I'm gonna have to do a little pass here where I make sure that I didn't do that anywhere else. That's not fun. There's no way that that's gonna be different for sub U. And so it looks like SLTU, I did the same thing for. What? Skago's XM player to sort of sound like music? Nice. I think I have some old XMs laying around that I did a long time ago, if you wanna test with them. I can't guarantee that that would be a pleasant testing experience. But funny nonetheless. And I think I did the same mistake here in Mult U. "31 code reviewers here, and none of us caught that," says QRAM. That's so true. Nice. I think it's so funny when people call those old modules keygen music, actually. Because I know them as demo scene music, right? But most people would, especially from the more gaming-oriented community, would, of course, know them as keygen music. It's kind of a funny thing. Why does Twitch cause molten error to stream on a laptop? Mine too. But that also might be OBS and everything else I'm doing, so... I do have a similar experience, generally. You know what I'm actually going to do? I'm going to look at the diff. Because I probably only made that mistake today. And at least this will show me what I touched today. They're looking pretty good. Yeah, I think we're okay. These are specifically from keygens, but were they made for the keygens originally? Because I know that a lot of that music gets put into keygens, but I would actually, I'd be willing to bet that probably oops, did I just delete a bunch of stuff on accident? Oh, that's why. That probably they were demo scene songs originally from old 90s Amiga demos. Look at that loop. I'm going to let this sit for a couple minutes, actually. It's probably not doing actual stuff, but... Yeah, I guess that one is made for keygen. That's funny. So I don't think this is going anywhere now. I think that this is stuck in this loop. FPGA Nugget, December 2012 was quite a while ago. Always knew those guys were out of their time. Those 212 kids and their rock music. Yeah. They were probably all stoned. You're 212 pounds. Yes, yes, as in banging rocks together, and then stoned as in having rocks thrown at them until they were dead. But is correct. Move away. Yeah. So this is stuck in this loop. So now would actually be a really good time to be able to pause this thing and start doing disassembly at different addresses. So I think that that's kind of the inevitable next step, is starting on debuggery things. But it's 5, so it's been 3 hours. I think I might call it quits here, at least for now. I'm getting pretty hungry. I want to go get some food. A what? I clicked my terminal and bad things are happening. Oh, there it goes. Anyway, yeah, I think this might be a pretty good stopping point. So I'm going to commit this. I might stream later today. I don't know if it's going to be this project, because I like to like announce those streams and kind of make it a more proper thing, because I know more people are interested and want to watch them. But I might stream some other stuff. Like I guess I mentioned that Elm project I was playing with. Might stream some of that. Also the other thing about my demo stuff is that I'm working on a renderer that's probably going to be a deferred render, and I just started with like polygons on the screen. So maybe that's a good thing to stream just because it's so early on in that project. Might be interesting. Let me know what you guys think, because I do kind of feel like streaming more today. I just don't know if I want to stream on this project. I kind of want to let the idea of the debugger thing kind of sink in my head a little bit. And I'm going to go get some food before that anyway. I usually end with questions, so we'll just keep doing that. Skit in Rust? Yes. Also, my Windows, yes. The Elm project is in Elm, of course, but my renderer stuff is in Rust. Your soda is in the mail? I don't know what that means. There's a Peth. Thanks for streaming. It was an interesting watch. Yeah, thanks for watching. Skit, how do I get the borrow checker to stop harassing me? That's a topic for another stream. Sure, thanks. See you later. Thanks for joining. And I always forget how to tag branches in Git. always forget. Move it. Okay, I gotcha. Git stuff. Git tag -l episode 8, I think is how I'm doing this. Let me go ahead and look. sleepy today. Yeah, that looks correct. Okay, so that creates the tag, right? And then I have to push it explicitly or something. Don't I? Yeah. Oops. Whoops. That's all the wrong characters. Is that not how you do that? Just do git push and then tags. That should work. I don't think it worked. How can I list tags? Git tag? Okay, apparently I didn't do it. What's the .8 option? Man, I do not remember this stuff. Oh, -L is gonna find the tags. That's funny. Ooh. I never use this feature, so I'm so bad at it. I do just want a lightweight tag, right? I don't think I need to do anything else. Okay. Finally. Good. That looks like it worked. Okay. That's what we wanted. Nice. So everything's pushed. Everything's been recorded this time. I didn't forget to do that. So yeah, I guess I'll put that up on YouTube ASAP. Yeah, if you guys have any questions, fire away. And I may stream later, but if I do stream later today, it probably won't be this project. Just for a heads up. I may use a slightly smaller font as well, depending on what happens. I love this logo. It's so simple, but it just is exactly what it needs to be. I believe it was Ryan Hebert who did that, so thanks again to him for doing that. Like Stell says, yeah, I would stream but no face cam, and it would just be reading the docs in SNES Music. I don't know if you've seen my earlier streams, but it is a lot of reading docs. That is definitely part of doing emulators. Nope, I think no questions, nothing. Then I guess I'll head out. So thanks again, guys, for watching. I hope to do this a bit sooner than later. I'll look at my calendar and I'll try to announce the next one as soon as I know. It will probably be sometime during the week because I have a fairly light week this week, and then the week after I'm going to Norway for a bit. So I might stream a few evenings there at CET time. We'll see. did last time I went, and that worked out pretty well, so I'll probably just do that again. So yeah. Thanks guys for watching, and I guess I'll see you next time.